remember your name and face on the day you were judged by the funhouse cast. We'll rejoice in your fall from grace, what it came to the sky like nothing shall pass.
So for this one, we are given the following. So we have n factorial over n to the ninth. So this section, again, just a refresher, this is on the ratio and the root test. So we're going to be doing actually 2 ratio test problems. There aren't a whole lot of root test problems, I don't think, because you have to have, it has to be the exactly like right conditions for those. So anyways, this one we're going to evaluate using the ratio test. We're going to determine whether it converges or diverges. Okay, so for here, this is our a sub n. Okay, and our a sub n plus 1 is then, if we plug in n plus 1 everywhere, n plus 1 in parentheses factorial over n plus 1 parentheses to the ninth. Okay, so we're going to use rho, remember the fancy p, and we have limit as n goes to infinity of a sub n plus 1 over a sub n. Okay, so if we plug these in, I'm going to get, so a sub n plus 1 is this, so I'm just going to write that in. So we have n plus 1 factorial on top over n plus 1 to the ninth power. And then this is over a sub n, but I'm just going to flip it now to save some space. So we have n to the ninth over n factorial. Okay, so now we're going to see what can we possibly simplify here, right? So this is going to be, well, okay, I'm going to break this down a little bit. So this, well, we have rho equals, and I'll just rewrite the limit, and then I'll explain something pretty important about whenever you have factorials. So in essence, what we have here, this n plus 1 factorial, this breaks down into n factorial times the next term, which is n plus 1, right? This is kind of like saying, that's similar to saying, what, like 5 factorial is the same as 4 factorial times 5. Okay, if that makes sense in terms of actual numerical values. But that's the concept here. That's what's happening. And then we have n plus 1 to the ninth times n to the ninth over n factorial. So this is good by decomposing that part, because now we can cancel the single n factorial on top and the one on the bottom. And as you can see, we can also cancel one set of parentheses, so the n plus 1 on top and then one of them on the bottom. So we're left with an 8 down there. So here is what survives, basically, is the following. We have an n to the ninth over an n plus 1 to the 8th on the bottom. Okay? So at this point, we can kind of just compare the powers, I would say. This is like a common sense exercise where you have, technically you could apply L'Hopital's, I don't know, 9 times, or 8 or 9 times, or something. But basically, what I'm going to conclude is that the top grows a whole lot faster in the long run. Whoa, that is a weird W. So the top grows faster, faster than bottom. Okay. So the limit goes to infinity. If you think of it on the other hand, let's say these were flipped, and then you would have the bottom growing faster, right? And that means that the limit would converge to 0. But in this case, it diverges to infinity. So our rho equals infinity, which is obviously greater than 1. So, a lot of so's, sorry. Then we could say, I'll just squish this in at the bottom here. So I'm just going to say that the thing at the top, the initial sequence that they gave us to evaluate, or to determine whether to determine its convergence. So this thing diverges. That's our conclusion here. Diverges. And you could even say by the ratio test. But yeah, so that's our conclusion, and that's it. And we'll do a similar thing on problem 11 point, or still from 11.5, number 32. Okay, so for this one, we have same thing, same setup, and now we have a 4 to the n times a sub n. And the given that they gave us at the top of these problems is that the rho for this is going to be 1 over 3. Okay, so this is a given. This whole thing here, that's all given in the problem. Okay, so what we're going to do is, again, use ratio tests. That's what we're going to apply here. And we'll just kind of work around this term here. So we're going to have our row equals, and we have limit as n goes to infinity of the following. And we'll have our a sub n plus 1. So we're going to plug in an n plus 1 for everywhere we see an n plus 1, over the normal, the given sequence, which is just that. And then we can decompose this, or break it down, however you want to say it. And this on top, that can break up into a 4 to the n times 4 times a n plus 1 over 4 to the n over a to n. And these 4 to the n's cancel. And as we see here, this part here, that looks like what we're given, right? So we can replace that essentially with the 1/3. Okay, so rho equals the limit as n goes to infinity of 4 times 1 over 3. Okay, and this is just 4 over 3. Okay, simple, pretty plain and simple. So rho equals 4 over 3, which is greater than 1. So by the ratio test, we can conclude that the following sequence or series diverges. So 4 to the n, a to the n diverges. Okay, and that pretty much does it for this video. I'm just going to say good luck on the rest of them, and I hope that helped.